Critical points on a curve. In this video, we will look at the critical points on a curve and how to find some of them manually and by using your TI Nspire. In the diagram, A is an absolute minimum. For this section of the graph, A is the lowest point on the graph. B, D, and G are zeros. They are the points on the graph where the function f of x equals 0. So f of x equals 0 at those points. C is a local maximum. Around the point C, C is the maximum value of the graph. E is the y-intercept, the place where the graph crosses the y-axis. F is a local minimum. In that part of the graph, F is the lowest value. H is an absolute maximum. For this part of the graph y equals f of x, h is the maximum value. Now we'll go through the same question manually and then using the TI Nspire. Draw the graph of y equals 12 divided by x plus x minus 6 for x is between 1 and 8. Use the graph to find the approximate values for A, the minimum value of 12 divided by x plus x minus 6, B, the value of 12 over x plus x minus 6 when x is 2.25, C, the gradient of the tangent to the curve drawn at the point where x is 5, D, display the graph on a calculator and find the gradient of the tangent to the curve at x equals 5. The first thing you need to do is to draw a table of values for the graph. Here is a table of values for the graph. If you look at the table very carefully, you'll notice that there is a big difference between the values for y for the x values 1 and 2. Because of this, it might be a wise idea to work out the value for y when x is 1.5. The values for x is 1.4 are 8, 1.5, minus 6, so y equals 3.5. This will make drawing the graph easier. Now we need to draw the graph from the table of values. When you have plotted the points, join them up with a smooth curve. It is from the table of values. The y value for x is 3 and x is 4 is identical. Y is equal to 1. Do not draw a horizontal line between x is 3 and x is 4. The graph goes slightly below 1 between these 2 points. From the graph, you can see that the minimum value of the graph is 0.9. B, when x is 2.5, draw a vertical line from x is 2.5 up to the graph. Then draw a horizontal line to the y-axis. When x equals 2.25, y is approximately 1.7. In part C, you are asked to find the gradient of the tangent drawn at the point where x is 5. So we need to draw a tangent, which is a straight line which touches a curve at only one point. So the tangent at x equals 5 will touch the curve only where x equals 5. Now we need to find the gradient of the tangent. So if we draw our little right angled triangle, the change in y is 3. The change in x goes from 2.5 to 8, which is 1, 2, 3, 4, 5.5, which is equal to 0.55 to 2 decimal places. You can do all of that using a TI Nspire. But on a TI Nspire. So open yourself a graph page. I'm going to change the window. I'm going to go from -1 to 9, -1 to 9. Okay. Now drawing your graph. 12 divided by x plus x minus 6 equals, move that up to the top, out of the way. Now you want to draw the graph x equals 2.25, so tab, get rid of the f2x, because we're going to have to do a relation in order to do an x graph. So x equals 2.25. And there's our graph. Now we need to find the intersection point. So slightly different to find the intersection point this time. So menu, geometry, points and lines, intersection points. Click on the first graph. Click on the second graph. So the intersection point, when x is 2.25, y is 1.58. Now, so it doesn't get messy, I'm going to open another graphs page. Change my window again to exactly the same. So, -1 to 9. -1 to 9. Okay. Draw in the graph. 12 divided by x plus x minus 6. There's our graph. Get rid of this. Right, it's very difficult to see where I want x equals 5. So if you go to menu, go to view, I'm going to put a grid on, and I want a lined grid. Right, I'm going to go and change the window. So go back to the window, I want to be able, so Windows settings, and instead of auto on the x-axis, I'm going to put 1, and then it will go up in ones. So I can now easily see where x is 5. So 1, 2, 3, 4, 5. So if I want to put a tangent line, geometry, points and lines, tangent. So go and find 5. So 1, 2, 3, 4, 5. Go up to where x is 5, touches the line, and press there. Press it again and it will stay. So there is my tangent line where x at the point x equals 5. So the gradient of my tangent is 0.52.